So we are Enigma. Basically, we're a data technology company that has applied our technology in two ways. One is we've built, at this point, one of the broadest repositories of public data in the world. I say broad, not large, because we're at Bloomberg, and obviously we know the empire that's been built here. But I say broad because you can look up the corporate registration of Coca-Cola in Pakistan and see that they were incorporated in 1964 over there in Enigma, right? You can look at cargo container shipments for whatever marble upgrades they may be doing in this room, the New York City building permits that were likely approved, as per code a couple of months in advance for the renovation of this room, all of these things on Enigma and will continue to be very much so a content organization. On the other hand, we've also empowered companies, partners, not-for-profit, people that we work with, anyone very much so, any organization to kind of leverage their own data with our technologies. And we find ourselves in a pretty unique spot in the data ecosystem, which I'll come talk to about a bit more naturally over the course of the discussion. So this is just briefly to give you a hint. This is the Public Data Explorer product that we put out. For me, kind of the biggest moment biggest kind of aha moment that we did here was this notion of search, right? It was the first data catalog that came out with this notion of actually searching through billions of records, searching through big data, so to speak, and actually hitting on actual data points inside the tables as opposed to the metadata in the table, right? Seems like a very small, from a feature perspective, but really eye-opening in terms of allowing users to discover data, right? That was the kind of aha moment that we had in our journey to understand, what were some of the most interesting problems for us in the data ecosystem. The kind of next thing that we did as we moved up the stack a little was start to generate signals from our data, start to understand, very specifically what were some of the meatiest problems that we wanted to solve, and kind of verticalize around those and take a stab at actually interpreting our data. God damn it, we're not just going to sell data, we're actually going to do something with it. And that's very hard for a data company, right? It's very hard for a data company to kind of build products with the commodity that it so relies on getting. It's a different mindset. It takes a culture of analysis, and it takes a problem-solving kind of esprit with enterprise as well. So I'll show you one of them real quick. This is one of the public ones. This one is a product which we call Smoke Signals, which was actually kind of born from a fair amount of work that we were doing in the assurance space, understanding the risk of buildings. And what we essentially did, and this is kind of kicking to some of the interesting parts of the discussion, was found a way to link very, very boring kind of, and I hope no one from the Department of Commerce is watching me, very boring kind of US economic data and kind of your more traditional census data, but take all of these questions that were answered in the economic data packages, probabilistically link them back to census tract parcels. So what we're doing for the first time is taking a question like, do you have a smoke alarm, which is answered on a metropolitan level basis, and no sexy math involved. I mean, for this room standards, but really a linked data problem of understanding the exact metadata attributes in each and every one of the data sets that could link this one question back to a cohort group on a much more granular level in the census data set. And what this got us was kind of a first eyes view of really this notion of block by block kind of risk scores for whether people had a smoke detector. And this is something that we deployed with the city of New Orleans, have people actually go out and kind of knock on doors and deploy smoke detectors this way. I'll get back to kind of the conversation, really the evolution of where we've gone. And and talk to you a little bit about why this thesis matters so much to us. We believe in something so central at Enigma, is that the analytics arms race that's going off over there just kind of get it wrong. That most of the problems exist not because we don't know how to analyze the data or we don't necessarily see the patterns of the data, is just because these data sets are born in different contexts and have different purposes, right? So I'm a manufacturer. This is a classic use case that we see all the time. I'm a manufacturer. I have an ERP system. I have a quality system. All right, okay, back in the day, I can kind of tie back my manufacturer system into the quality system, create some linkages in between the data, all good, right? Suddenly, I have a couple other ERP systems in different versions, and part of the world got upgraded to SAP, but we're the boring part of the Fortune 500 because we're not performing as well, so we still have this Oracle thing. Okay, we could create yet another bridge. And then, boom, suddenly I have a new FDA requirement or a new, this is like in the food processing space or something along those lines, that when I ship my goods, I actually have to measure the temperature of each and every shipment, and if that temperature drops below a certain threshold, I need to audit this entire shipment back through the chain, and now I'm kind of, messed, right? I have no idea of what a batch is, in the quality system, no idea what it is in the actual assembly line that produced it, no idea what it is in the cargo container shipment that produced it. These sort of what I call logical and semantic silos are our fundamental kind of, these are the problems that we rally our entire company around. And so I just wanted to give you that kind of heads up before I shift into a slightly different space. But that heads up being that we think linking is the problem, and what we bring to bear, the sort of products that we bring to bear, have this key aspect of offering an operational model for open data in the enterprise. So what do I mean by operational? I mean mostly that all of this work is done in a one-off way, right? If we're talking about downloading this domain expertise of metadata onto a company, that needs to happen in a kind of pipelined and routine way. If we're talking about ingesting data, that needs to happen, especially if the problem is linking multiple different silos of data. That needs to happen in a much more operationalized way than we've conceived of before, right? If I'm, looking at a couple key log metrics, couple key log data sets, and some, perhaps shipment data and so on and so forth, it certainly can be big data, but it's not kind of very, very wide, right? And so that is a problem that we know well, and that's a problem I kind of want to zoom in and focus on for the aspect of the job, which I think is absolutely the hardest in the data business. Can anyone guess what the hardest part of the data business is? ETL. Thank you. ETL. Sorry, I'm going to jump there. So we have had a problem with ETL, forever. Everyone has a problem with ETL forever. It is no surprise that the very first hands up was ETL. And I just want to explain to you this one slide. This is like a very early back in the day, like census of all of the programming languages that we use to acquire data and the different kind of lines of codes and commit. If you see the Perl up there really high, it's because my co-founder and I we'd get down and dirty with Perl, and that's how we started. And there's a big backlog of scrapers and parsers and so on written there. But we kind of built this really cool kind of middle gate library in between all of these languages that would share functions and so on and so forth. And it was just not hitting the scale that we needed to acquire, the 100,000 plus data sets that we have in the system and kind of maintain them. And it was just not operational enough. It did the job. It processed data really fast, but from a, small team, a couple of people, so on and so forth, we just couldn't manage it. So we did what good technologists do, which is just kind of take what they have, put it out back, and shoot it, and think about how to build something new. And we came up with this thing called ParseKit, which, other than the kind of Apple fanboy name, is really awesome. I do like the name, just as a FYI. But really what it is kind of this notion of critical data ingestion unified around a standard language and pipeline. So what we did is we said, okay, let's look at what's happening from a trends perspective, in terms of programming languages, in terms of operational efficiency, immediately we gravitated towards the sysops space, right? What was happening with Chef, what was happening with Ansible, all of these good technologies that made it possible for small teams to deploy big stacks, right? And so what we did was like, okay, boom, we got it. We can design an entire DSL and language. It's more of a recipe-based approach to parsing, and it has, standard set of libraries and so on and so forth. Very convenient. You can kind of piece it together, and I'll show you some code in a second. And then we could build around that. We could build our own platform for executing these things. We can actually treat the code as data if it is a nicely, rich syntax enough that we can actually get back from the code a certain amount of metrics. And so I'll show you what ParseKit looks like, and then I'll talk about it a bit more. So ParseKit, for the techies in the room, does very much so look like that kind of step action pair sequence of things, right? So I'm loading some dependencies for the specific libraries for the specific job. This is a parse, by the way. This parse, what it does, grabs some data from the FDA, does a couple transformations, loads it into the system. So I'm creating a step, have an action for that step that imports some code, another step. I'm fetching data from the FDA, calling http.download files. Developers can rely on HTTP download files always delivering the same job. In the background, there's like hundreds of commits optimizing the heck out of HTTP.downloads, right? And that's the guarantee that this model gives you when you break out into a DSL. It feels much more natural for the developer. The developer is basked in a really awesome experience, and a lot of the harder work is shifted on the side. I'll run the parse real quick just to show you. So I'm running the parse, getting the data, and I'll show you just a really cool kind of convenience function, which people have probably never seen in ETL before. At least I haven't seen this in ETL, and I stand to be corrected. Come to speak to me after. This is a breakpoint, right? Parsing is about not knowing the right regex for that crappy data set that you have, right? And so inserting something as simple as a breakpoint in your flow, I'll let this parse finish, then I'll run it again. It's kind of awesome, right? So now I have this thing. It's going to download this file. It's going to tell me hey, there's a breakpoint here. Do you want to inspect the data? Do you want to give it a second? It's a real demo. Not BSing you here. It's not a video or anything, because I definitely did have that as a backup at TechCrunch. We were the only live demo at TechCrunch Disrupt 2013, apparently. I was told that 6 months after, and I feel like I would have, kept my weight had I known we could do that. It's a really stressful time. So, whoops. Yeah, let me save. Classic. There we go. There's my breakpoint. Can expect the metadata. Oops. See what file I got, where it went, what the session was in the browser, all of these cool things that really make the developer experience around ETL 100 times better, right? Things like, even inspecting the record, treating, every single step action pair as something that yields data as well. So we have been wrapping that in a platform that kind of runs our own data. This is the same parse. And as you can see, because the step action pairs are data in themselves, and this, I tell you, will be a trend, your code will look more like data than it does today. I can look at a specific piece of code, this specific transform, and see oh, this is how much it took me to, this is how much it took me to do the transform or strip the white space as opposed to anything else, right? I can see, how much if my disk written is consistent, and kind of be polling those things and putting learning algorithms behind all of this data as well. So I'll get back and just kind of close up here. Oops. With all of this good stuff. Hide, hide, hide. There we go. And just kind of finish with last point is, for us, this notion of open data is really the freedom to access all of the information you need to make a kind of decision in a unified, seamless way, i.e. not clunky, right? I need all of the data now. I need to be able to search it. I need to be able to ingest it. We know this. This is a mantra that everyone sells. They've certainly done it in kind of the platform side of things. But for me, I think where the industry is a little behind and a little back is that things need to be unified. You can't just be ETLing left and right and writing things kind of randomly and shoving things around the way. Make it more like a factory. Make it industrial. Operationalize it. And think about kind of the semantic component when you do that too. So that's pretty much it. We're Enigma, and we're hiring. I have to plug this, or else they'll be pissed at me. Thank you.
Good. Thank you very much. So just one question from me, and then I'll open it up to people. Maybe that was actually your last slide. I'm just curious if you could tell the audience about what happened since 2013 and company, customers, fundraising, all those things.
Great. So we won TechCrunch in 2013, spent a really interesting time learning about some of the kind of juiciest problems for us to solve with our own data, found some really awesome ones. Kind of continued to verticalize around those. We raised an A in 2014 with Comcast and Amex, and that was really awesome. People really believed in our vision, and honestly, our investors kind of see the vision grow, but always have a sense of that seed. It's really, really awesome. And then we had some great customers. From some of the strategics like Amex to Merck Pharmaceutical, who is one of our larger customers and has just been an amazing supporter. It's kind of awesome to see a customer be both a content and infrastructure player, because I think what we're doing a little bit and what we're realizing is that this industry needs to behave much more, and companies in this industry need to behave like an ecosystem, right? They need to accompany clients from beginning to an end, and they need to do that in a way that really helps them solve their problem and not kind of help them to kind of maybe solve their problem one day. And we've been doing that really well, certainly in the insurance space, in the manufacturing space. And then last March, we raised a $28 million round from NEA, who are really awesome folks and have been helping us with everything from how to run the business and how to make kind of killer technology. And so we're growing pretty fast. We just moved offices. Thankfully, my wife is a rug dealer, so we got the hookup. Not drug dealer, rug dealer. So
you would not need to raise VC money.
I would not need to raise VC money. It's kind of funny. I'm from Morocco, so she's at a party, and she was like, "Oh, I get great stuff from Morocco and Afghanistan." It's way too much like entity disambiguation over there. So yeah, no, we've been having a good time.
All right, great. Congratulations on the journey. Questions? Okay.
Based on the traceback that I saw, I'm assuming that this stuff transpiles into Python at some point. And I also noticed that you have an empty PyPy package with nothing in it. So I'm wondering if ParseKit is going to open source at some point.
Okay.
Or maybe it already is. I don't know.
So that's a great question.
Do you have an announcement?
No, I don't have an announcement. I think you're absolutely right in what you said. ParseKit may open source one day. That is exactly why we were, this kind of domain camping thing has gotten all the way down to the PyPy packages. So we had to hold our name there. A part of the code base, we're definitely already thinking about that sort of stuff. And yes, it does compile back to Python, specifically because it is one of the most, it's the largest currencies, the US dollar of programming languages. So we need to, ParseKit is basically, if you take what you know today, the Informaticas, the GUIs and so on and so forth, not super flexible, do a great job, right? The custom code can do a killer job, but really hard to maintain. And so we're somewhere in between, and we feel that the extensibility is a very important aspect to developers, and we think that Python was the natural choice for that.
Hi, just a quick question. How are you sure that you're asking the right questions? Because I was thinking about the fire alarm that you are talking about. Lots of people have fire alarms which don't work.
Yes.
Okay, so what do you do in your model? Do you adjust with a variable error? How do you deal with that issue? Or is this an issue?
I think in this industry, it's very important to be skeptical, right? The data is there to kind of create a picture of the world, but that's never going to be an accurate picture, right? So if you don't have, some of the best companies I know have very strong feedback loops into their data, and that's an even better technology than the underlying model. The underlying model is just there to buttress the initial assumption, and that the technology will continuously learn about the world. So I think approaching the analysis with an attitude of skepticism and saying, hey, we deployed, it didn't really work, we're wrong, not the world is wrong. Because I've certainly seen the latter, and it's kind of alarming, and I'm happy you bring that up.
Thanks, very interesting. I had a momentary flashback because my last company, over 10 years, I spent a lot of time working on a lot of similar things, so try not to personalize it too much. But my number one question is an issue that plagued my last business, and that is with open data. You can make FOIA requests, file lawsuits, but those are expensive, time-consuming. For me, at least in my last business, the data is not useful unless we can normalize it across a broad set of geographies. So let's say like health code violations. Right? Those are inherently done at a local level, and they're 4,800 counties. Not that they all have different, but it's A to Z, 1 to 5, et cetera. And that normalization stuff that can't be automated in that way because you're dealing with different schema. And you can look at any kind of collection of data across different variety of actors, and you're going to find a lot of these similar problems. And it might suit a few customers, but it's not going to suit the others because these 3 states in New England have some weird delineation of, for instance, the township, right? Just a strange concept. So there are lots of ways to gloss over that, but in general, how do you deal with this issue of normalization and providing a lot of value to the entire corpus of what the data collection might truly be representative of?
It's kind of our whole shtick, right? Our whole shtick is normalization is the problem in data, that you need to fight towards it. I'll add one more example that colors yours is like Michigan state liquor license, types are in the hundreds of varieties. Because of the days and hours that they're allowed to operate in the business, they just decided, hey, we're going to have a new category class for liquor licenses that actually correspond to different times of operations and so on and so forth. Think about normalizing those with another state that has like 3, like on-premise, like wine and so on. The normalization problem is huge. What we try to do, and kind of what we aim for, is just a user experience where as much implicitness that you can offer to a user in the process of normalization, in that hard work that needs to be done manually, you will kind of win their heart, their mind, and their effort, right? So think about things like automatically being able to detect entity types. And this is one thing that we do well with the platform product. We have an entire corpus of data upon which to train. So when people kind of upload their own data and we deploy things behind the firewall, we're already learning things about entities that they may have not known before. Whether there's a silver bullet here, there's absolutely none. I'll be the last person to tell you that. I think what we've learned, though, is that this is the problem, right? That Michigan, that one data set that you mentioned, it's local, but more importantly, it only serves the purpose of reporting against this one specific law. No one sat out there and said, hey, this data set is for the purpose of optimizing, I don't know, like ad revenue sales or so on and so forth. So it basically betting on metadata and slowly starting to improve the focus around those technologies.
All right, Hicham, thank you very much.
Thanks, Matt.
Thank you.